We talked about this question today in class, and we found the derivative using implicit differentiation. And we kind of stopped after we solved it, and we didn't go any further with the algebra simplifying. And I want to show you uh, that we could have done that. Um, some statements I made in class today that it would have been easier to apply some algebra early on in the derivative, but I'm going to show you how you do that if you neglected any algebra during the process of finding the derivative and you waited to the end to simplify everything. So we'll start by doing um, the derivative with implicit differentiation. Notice here that we've got the product rule, and we're also going to have the chain rule because of the radical xy. Okay, so those are the two rules we're going to use over here. And the other things on the right and left, or I guess on the right hand side, we'll use the sum and difference rules, but there's no chain rule or product rule there. I'm going to rewrite the left hand side as x, y raised to the 1/2 power equal to then the right hand side of x minus 2y. Okay. The chain rule tells you to bring that 1/2 down in front. So we go 1/2, and it's going to be times the inside xy, and then I subtract 1 from the exponent, and I get negative 1/2. Okay. Now, the chain rule also says that you got to then multiply by the derivative of the inside, and now that it's x times y, that's going to tell us that we have to use the product rule inside the chain rule. So I'll take the derivative of the first part, which is x. Oh, I'm sorry, the derivative of the first part, not x. The derivative of the first part is 1 times the second part, which is y. Okay. Then I want to add to that the first part times the derivative of the second part. So the first part is x. The second part is y. Okay. Now we're taking the derivative of y with respect to x. Okay. I'm going to approach it just like I would if the variable was x. I'll take the derivative. Okay. It's going to give me 1. But because it was the derivative of a y, I need to write dy dx with that um, variable of x. Okay. So now I've taken the chain rule with the 1/2, xy to the negative 1/2, and then working on the inside, I get 1y plus x dy dx. Okay, and it should equal, the derivative of x is 1 minus, now the derivative of 2y, there's again when I'm taking the derivative of y with respect to x, so it's minus 2, and then I got my dy dx. Okay, now in class, remember, we always want to take our dy dx's to one side. In order to do that, I need to distribute this stuff to the things I've got in brackets. So it's going to end up with 1/2. We put the y out in front if we want to, uh, and then xy to negative 1/2, plus then 1/2 x times xy to negative 1/2, and then I've got my dy dx there. Okay, it just gets rid of these brackets, so then I can move over my 2 dy dx to the left hand side at the same time. So we got 2 dy dx here, and I'll set that equal then to the 1 that's left on the right hand side. Okay, now I still have some things I need to move over. Um, this, for instance, does not have a dy dx with it, so it'll get moved over. So I'm going to have a 1 on the right hand side minus a 1/2 y xy to the negative 1/2. Okay, and then on the left hand side, we've got basically going to be this stuff right here left over. Okay, so I'm going to factor out the dy dx at one time. So dy dx here, and then that's going to leave me with the 1/2 x times xy to negative 1/2 plus 2. And then to solve for dy dx, I'm going to have 1 minus 1/2 y xy to negative 1/2 all over this stuff of 1/2 x xy to the negative 1/2 plus 2. Okay. Now, we do have some negative exponents in there, and that's a problem in terms of simplifying. So I'm going to write dy dx is equal to, I'm going to leave the numerator, that whole thing, but I'm going to kind of simplify it and make it look nicer, get rid of this. This negative 1/2. That's going to be 1 minus, I can put that y up in my numerator of this 1/2. So we got y, the 2, obviously in the denominator, and now the xy to the negative 1/2, that can come down here as xy. Okay, so that right there, 1 minus y over 2 radical xy is that numerator right there. Okay, now the denominator will do a similar thing. The 1, I'm actually going to put the 2 up front, make it a little bit consistent with that one there. So the 2's up there in front, and now I'm going to have plus, that x can go up in the numerator, and now the denominator is going to be xy to the 1/2, or radical xy. Okay, and I guess I forgot the 2 that went with that fraction, so there's 2. So that there is this denominator, written so that I do not have negative exponents. Okay. Now what's nice about this is that we can go through a little bit more algebra to simplify the overall fraction. You got a fraction divided by a fraction here, so we want to kind of get rid of that. In order to do this, I'm going to need a common denominator. I'm going to combine this 1 minus this stuff. I'm going to put that all as one fraction. So the common denominator for this is going to be 2 radical xy and 2 radical xy. So I need to multiply that 1 over 1 by that fraction there. So I end up with 2 radical xy over 2 radical xy minus y over 2 radical xy. Okay, so that's just changing that 1 so that it's 2 radical xy over 2 radical xy. Nothing big there. Do the same thing in the bottom, in this denominator. Okay, the common denominator is going to be a 2 radical xy. So I need to multiply by 2 radical xy over 2 radical xy. And now remember this 2 here is a 2 over 1. So up 2 radical xy times 2 is going to give me 4 radical xy. The bottom is going to give me 2 radical xy. And then this part here stays what it is. It's x. It already has the common denominator, so it's x over 2 radical xy. Okay. So now cleaning that up a little bit, since I've already got the common denominators now, it's going to be 2 radical xy minus y all over 2 radical xy. Okay. Right there is that stuff. Just combine one fraction. Okay. I'll do the denominator in green. Okay, that's going to be 4 radical xy plus x all over 2 radical xy. Oh, xy. So that's what that thing there ends up being. Okay. Well, now notice that you've got a fraction divided by a fraction, so when we have that, we want to invert the bottom fraction, find its reciprocal, and multiply it by the top. So we're going to have 2 radical xy minus y all over 2 radical xy, that's the top. And I'll multiply it by then the reciprocal of this stuff here on the bottom. So it's 2 radical xy all over 4 radical xy plus x. And now the nice thing here is that we recognize, hey, that's going to cancel with that. And I'll end up with 2 radical xy minus y all over 4 radical xy plus x. And that, remember, is dy dx. So that's my final derivative after using a lot of algebra to simplify it. Okay. Um, if we go back up, this right here is all the calculus. Everything after that, to get to a simplified version, all this stuff here in the middle, that's just algebra. Okay, and remember, the hard part about calculus is the algebra.